Example 5, we are still graphing, but now we're going to graph transformations of our logarithms, of our logarithmic functions. So example 5a, we are going to graph y equals the log base 2 of x minus 3 plus 4, and then compare to the parent function. Well, our first step here, we have to figure out what is the parent function. So at its heart, we have a logarithmic function, and that log is base 2. We have the log base 2 of x. So that's our parent function. So when we're graphing this y equals log base 2 of x minus 3 plus 4, let's start off with our parent function. And then this minus 3 inside and the plus 4 outside, those are just transformations. Those are two different translations that have happened. So let's first start off thinking about what on earth does this mean? Y equals log base 2 of x. Well, this means 2 to the y power equals x. So then to graph this, let's start off making our table of values the same way that we did in example 4 with our x and our y values. And we still want to use those -2, -1, 0, 1, and 2 values. But again, those values we're using for y because we can take 2 to the negative second power. We can take 2 to the negative first. Okay, so 2 to the negative second power is 1 over 2 squared, which is 1/4. 2 to the negative first power is 1/2. 2 to the 0, 2 to the first, and then 2 squared is 4. Now, what other transformations happened? Well, this minus 3, it's inside. That's going to translate our graph right 3. So if we're going right 3, we need to add 3 to all of our x values. So this becomes 3 1/4. Add 3 here, we get 3 1/2. Add 3 here, we get 4, 5, and then 7. Then this plus 4 at the end, it's outside. It's going to move our graph up 4. So add 4 to all of your y values. We get 2, 3, 4, 5, and 6. And then these will be our points when we are graphing. So 3 1/4. -2 would be somewhere around here. 3 1/2. Oh shoot, 3 1/4, 2 is up here. 3 1/2, 3. 4, 4. 5, 5. And then 7, 6 would be up here. Okay, so then we connect our dots. And this is what our graph looks like. Now keep in mind that our logarithmic functions are always going to have an asymptote. So in this case, because of our translation right 3, that asymptote is translated right 3 from where it normally is 2. Okay, so I'm just going to make the note on here too that the asymptote would be the equation x equals 3 here. X equals because it's a vertical line, and then it's translated right 3. All right, so just like when we were transforming our exponential functions, start off with your parent function and go from there. Last little piece that I almost forgot in example 5a is to compare to the parent function. And that's just describing our transformations. So we have a translation right 3, and then our translation up 4. And we had already thought about this when we were changing our table, but just to write it out here. Translated right 3 and up 4.